Okay, so we're given the diagram with the quadrilateral, which is PQRS. Right. Remember what I told you that with regard to the. Right. So the first question says calculate the length of PQ. So this is our point P. That's point Q. So if we want to calculate the length, that will be straightforward. So it will be PQ will be equal to the square root of x1 minus x2 squared. Okay, you can start with x2 as I explained in class. You can start with x2, or you can start with x1. It's your choice. So y1 minus y2 squared. But it's very important to remember that if you start with x1, you have to start with y1. Right? Then we substitute. So if I consider the coordinates of P as my x1 and y1, then I'll end up having 7 minus, okay, minus 6 squared plus my y1 is going to be 4 minus y2, which will be 6 squared. All right? Then I'll get PQ equal to the square root of 7 minus 6, that's a 1, so we get 1 squared plus 4 minus 6, that's negative 2, so we get negative 2 squared. So eventually you get the square root of 5 units as the length of PQ. Okay, so if you did the question, you can just mark your work there. It's very straightforward. Okay. Then the next question says, if T is a point such that is the midpoint of QS and the coordinates of T are given as 7 over 2 as x and y is 7 over 2, we need to determine the coordinates of S. So here, what this means is we need to calculate the coordinates of S. Point T is somewhere there, and we are given the coordinates of Q, right? So we have to use the coordinates of T and the coordinates of Q. Now, to do this question, we have to use the midpoint formula, but here the midpoint is given. So when you're doing a question like that, this is 3.2. Our midpoint formula, we have to write it as mx y is equal to x1 plus x2 over 2, y1 plus y2 over 2. Alright? Now, I want you to be aware that for our question, this x here is actually xt and this y here is yt. And this m here is t. Okay? So, we equate this xt to that, whereby we'll substitute a value for xq there. Okay, we'll substitute the value of x at q, right? And then, furthermore, we equate this yt to that. Here we substitute the value of y at q. So if we do that, we'll get 7 over 2 is equal to x1. In this case, my x1 is going to be 6. So that will be 6 plus the value of x at s, I'll call it xs over 2. Right? Then you cross multiply, you get 14 equal to 12 plus 2xs. Then you take the 12 to the left, you get 2 equal to 2xs. Divide both sides by 2, you get xs as a 2. Alright? That's the value of x here. Okay? It's going to be a positive 2. Then, for y, we are going to say the value of y at q is a 6. Sorry, at t rather, it's 7 over 2 as well. So, we say 7 over 2 is going to be equal to y1, which will be 6 plus ys over 2. Then we cross multiply, right? And then we will get 14 equal to 12 plus 2ys. And then you get 2 equal to 2ys. So ys is going to be a 1. Therefore, the coordinates of s are going to be x is 1 and y is 1. Okay? And those coordinates of s, they are also provided in the next question, but you have to show that they are equal to 1 each. Okay, I hope you can see what I did there. I used the midpoint formula because and then I created two equations, one in terms of x and one in terms of y. Okay, so be aware of it. So this is xs equal to 1. Okay, all right. Any questions? All right, so let's move on to the next question. Now, the next question says, if the coordinates of S are x is 1, y is equal to 1, which is what we got, show that PR is equal to QS. So we now know the coordinates here, right? And we are now being told that PR, that is from here to Q is equivalent to QS, that is from here to there. So the question says if the coordinates of S are 1, 1 and show that PR is equal to QS. Right? This question we can, if they are equal, it means they intersect at a common point. Therefore, the midpoint of SQ must be equal to the midpoint of our of PR. The midpoint of PR must be equal to the midpoint of QS if they are equal. So all we have to do is for 3.3 we have to calculate or we have to show that the midpoint of PR is the same as the midpoint of SQ. Okay? So I'm going to use my midpoint formula. It's M, which will be x1 plus x2 over 2. Please take note that here I'm now calculating the coordinates of the midpoint, which is point T. I know those coordinates because they are given in the previous question. They are here. So I just have to prove that if I calculate the midpoint of PR, it's going to be equivalent to the midpoint of QS. Okay? So if I get the same coordinates of the midpoint of PR as the coordinates of T, then I can conclude that therefore PR is equal to QS. Another way would be to calculate the lengths of QS and the length of PS. Okay, that could be another way, but that's a longer method. So this will be y1 plus y2 over 2. So that m there is going to be equal to my x1 is, I'll start with the coordinates of p, so that will be 7 plus 0 over 2. Then the coordinate of y at p is 4 plus the coordinate of y at r, which is a 3. Then I divide by 2. So I'll get 7 over 2 and 7 over 2. Now, because of this, I can say therefore PR is equal to QS because their coordinates, because the coordinates of their midpoints are the same. Okay? But this is not the only way. As I said, you can calculate the distance of QS, the distance of RP. If they are equal, then you can say therefore PR is equal to QS. All right? Any question there? Right, if you're quiet, then I'll assume that you're following. Then the next question now says, show that QR is perpendicular to RS. So, QR is perpendicular to RS, so we need to show that this angle is equal to 90 degrees. Okay, we need to show that the angle R is equal to 90 degrees. Now, if two lines are perpendicular, it means that the product of their gradients must be equal to -1. So I have to calculate the gradient of PQ, the gradient of RS. Okay, so that's where I'm going now. So let me okay, let me calculate. I am going to calculate. I'm now doing 3.4. So I'm going to calculate the gradient of PQ. So I'll say MPQ is equal to YP minus YQ over XP minus XQ. And this is equal to, right? So my YP, so it's supposed to be RQ. So that's RQ. Uh, that's RQ. So this is R. This is also R. Okay. So, so the coordinates of R, the y value is 3 minus the y value at Q, which is 6. And then the x value at R is 0. The x value at Q is 6. So if I simplify here, I'll get -3 over -6, which is a half. Right? So I've got the gradient there of RQ is a half. Then I now need to calculate the gradient of RS, which will be YR minus YS over XR minus XS. And that's equal to my YR is 3, my YS is a 1, and my XR is 0, my XS is a 1. So I'll get 2 over -1, which is -2. Okay, so this is MRS. So MRS times MRQ must give me -1. So MRS is -2 times MRQ, which is a half. I'll get -1. Then we say therefore QR is perpendicular to RS. Now it's very important for you when you are doing this question to write this, okay, and also to come to this point. Okay? Because you have to prove that the product of their gradients is -1. Alright? Are you following there? It's not that easy to get those 4 marks. You have to make sure that you do it the proper way. So you must know that the gradients are going to give you a product which is -1 if the two lines are perpendicular. All right?
Sir.
Okay. Then the next question. Now the next question says,
Sir.
in the diagram, okay, it's the same question, but hence what type of a special quadrilateral is PQRS? Right. Now, remember we have got 6 quads. This quad, it can be a kite because we have already proved that the diagonals, they intersect at a common point, therefore they are equal. Okay? The diagonals intersect at a common point, therefore they are equal. So it can be a kite, it can be a trapezium. Right? Which means we'll be left with only 4 possibilities. A rhombus is a possibility, but because this angle is 90 degrees, it can't be a rhombus. Okay? Because the internal angles of a rhombus are not 90 degrees, so it's not a rhombus. It can be a palm, but that angle is 90 degrees, so it's not a palm. So it's either it's a square or it's a rectangle. All right? My suggestion here is that I would put, in my case, I would put rectangle, right? It's a rectangle. right? And then my reason is that the diagonals bisect, okay? Plus, I will also mention the fact that there is at least one interior angle which is equal to 90 degrees. The rectangle, because the diagonals bisect and also one interior angle, or rather I'll say also at least one interior angle is equal to 90 degrees, which is this angle. So it can be a square, but for it to be a square, it means you might have to prove that the four sides are equal. So the best answer would be a rectangle, right? But it can be a square, but you have to prove now, to say it's a square, you have to say why you're saying it's a square. So I'll put a rectangle, right? If you say it's a square, then calculate the length. Right? Then the last question says calculate the size of RSQ. So we're saying we're going to calculate RSQ. So if you join those angles, we want to calculate the size of this angle. Okay? Now to calculate that angle, you may have to use trigonometry, right? That is trigonometric ratios. So I'm going to calculate the length of QR. Okay? Let me check if I calculated before. And I didn't calculate the length of QR. So I'm going to calculate the length of QR in order for me to calculate. Calculate the length of QR, I'll also calculate the length of RS. Then I'll use trig ratios. Okay? So that's what I'm going to do. Alright, so for 3.6, so let me start this question on a new page. Right. Okay. So for 3.6, I will calculate the length of RQ. So RQ is going to be equal to XR minus XQ squared plus YR minus XR. So YR, YQ. Right? Then if I substitute here, my XR is 0 minus XQ, that's a 6. My YR is 3, and then YQ is 6. So if I simplify that, I will get 0 minus 6, that will give me minus 6 squared, plus 3 minus 6, that will give me negative 3 squared. So if I simplify this, I'll get 36 there, and I'll get 9, so I'll get square root of 45, which is the same as 3 square root of 5. So that's RQ. Alright? Then, I need to calculate the length of RS. Okay? RS. So RS is the square root of XR minus XS squared plus YR minus YS. Okay, my XR is a 0. My xs is a 1. yr is a 3. ys is a 1. So I'll get the square root of minus 1 squared plus 2 squared. And that should give me square root of 5. Okay, so I now have my length. So to calculate this angle, right? This would be my reference angle, so this would be the opposite side. My hypotenuse is SQ. I don't need that. I've got my RS, which is going to be my adjacent side. So I have to use tan to calculate that angle. Alright, so I found the length of RQ and I found the length of RS. So I have to use trig ratios to find the answer. So this angle is the one that I want. I'll call it theta. So it will be tan theta, right? Tan theta, or I can just put the actual angle RSQ. So it will be tan RSQ is equal to the opposite side is going to be RQ. RQ is 3 root 5. And my RS is square root of 5. So it means tan RSQ is going to be equal to 3. So RSQ is going to be shift tan of 3. Okay? Then you have to take out your calculator. Right? Check out the calculator. So it will be shift tan of 3. Right? And that will give you 71.57 degrees. So that will be the size of angle Q. Okay. That will be the size. Now this angle here, it will be a hint that we are dealing with a rectangle, because for a square we are supposed to get 45 for that angle, and that will be 45. So this is indeed a rectangle. Okay? We are supposed to get 45 and 45. That should be a rectangle. Alright. So I think for today I'll stop here.